Hi there, just a quick update on the plasma build. Done quite a lot of work. It's been a challenge, to say the least, but we are now getting cuts. Here's the skeleton cut edge. They are, focus, they're good cuts. Can't really see, but I'll show you on an edge piece in a minute. You'll be able to see exactly what I'm doing. I've done away with trying to follow the rack. So what we've done now is that we have built quite a tidy little spring situation where we can just adjust this if it starts skipping. I also had to, you can't really see it there, but yes you can. That grub screw, the grub screws that comes with these pinions are just pathetic. They're like 3mm grub screws that's got some kind of weird Allen key size. So I've put in some 6mm just to beef it right up. So yeah, got that one. That's on both sides because we've got Y1 and we've got the Y2. So over this side, of course, identical setup. The other thing that I've done, of course, is here you can see I've just packed it down a little bit to make sure that we get the pinion as close to fully engaged as possible. I've got the Hall effect sensors, they're in, wired up properly. We've got everything with heat shrink on. It's all homing properly. Everything about it is actually working exceedingly well. For a minute, though, the X-axis spring loading was a little bit more difficult, but I've done exactly the same thing. So I don't know whether you can see that, but basically got the long stem here, got the threaded part there, managing to miss all the location bolts, and it's rigid. It's nice. It works well. Again, we've got the Hall effect sensor there. That's all working. That's fine. I've still yet to weld that. I'm going to TIG weld that once I dismantle it. It's got to be dismantled for powder coat anyway. So that's pretty good. Cutting out stuff for my machine because I think I've told everybody this is a customer's machine. I've got an ohmic ring on here. Took off the Jubilee clip and put an ohmic ring on, just testing it really, but I actually prefer the Jubilee clip, but there we go. Here's the Hall effect for there. I had to kind of it doesn't detect aluminium very well. It's got to be very close to aluminium. So what I've done is that I've just tapped the back of the bearing and just put a screw and a washer in there. It works brilliant. So easy fix, simple. And that's about it. When we're looking at edge cuts, I don't know whether we're going to actually get to see how good they are, which is a bit unfortunate, but yeah, it's not. Oh, will that help? No, it doesn't help at all. That's a pity. If it would just focus, you'd be able to see. Yeah, I'm struggling to get it to focus, but darn diddly darn. Suffice it to say that these edges are pretty good. There we go. So you can see it there. It's good cut. It's pretty darn square for plasma. You're always going to get a bevel with plasma, but there you go. I mean, that's quite square if you ask me. There's the cut quality, so you can see that it's pretty good. And that's no cleanup, so feeds and speeds are bang on, so there's next to no dross. That's what you're looking for. Hypertherm even stipulated themselves that get the feeds right. Once you get the feeds right, you'll find that there's little dross on the components at all. So down here, so here's yet another one with the same, obviously from the same job, cut job. It's fine. Again, dross next to none. So that's dapping on as well. That's That's going on around about 1700 mil a minute, so 1.7 meters a minute, which is cutting pretty quickly for 5mm plate. Still got another screw to put in there, which I just noticed. Just to hold the sensor, just stop it from moving, because it can twist, especially if that one comes a little bit loose. Although I will be using Loctite on everything once I put it back together for real. So anyway, I thought I'd just tell you an update. I'm still waiting for the cabinet to turn up to house all of this. So as soon as that turns up, I'll stick that in. But again, that My Plasma controller is just superb, especially with the Plasma interface. So there you go, that's the update. I'm all but there. I'll make probably one more video to show. I want to brace the frame, because there's a little bit of wobble in the frame, which is wobbles a bit extreme. It's not that, it's got a little bit of vibration, but I know it's coming from the frame and nothing else. So we'll get that straightened out. We'll put some diagonals in there. We'll get the water tray in, and we'll get the torch hanger in there, and that is going to be it. There is going to be nothing else to be done on it. So hope you've enjoyed this build. The next build, of course, is going to be my own, which is double the size of this. So it's going to be a lot longer. It's going to be a little bit more challenging, a little bit more interesting. I'm just looking forward to doing it. I'm going to do it almost identical, just longer, because it's an easy thing to do once you've built one or two of them. So I will keep you posted on there, and I'll try to do a little bit more kind of tutorial build on it, just so that you can see how all of this is done, because it's very easy for me to say, look, this is what I've done so far, this is what I've done so far, but if I'm not showing anybody how to do it, it's not great, is it? So anyway, I thought I would just fill you in on that. If you like the content, like the video, please like and subscribe. I'm always after more subscribers. It's only, as I keep saying, it's just to spur me on to make more videos, really. So yeah, hit the like button, please subscribe. If you don't like, let me know what you don't like, rather than just doing a thumbs down. Tell me why, because it could be something that I'm missing, and I would like to, I'm always looking to improve. So there we are. Hope you enjoyed it. Take care now. Cheers. There. Well, we're back again. I just stopped it so that I'll be able to show you some of these pieces being cut out. I've eliminated a lot of the wobble that I was having yesterday. I've beefed up the plates, hanging plate there. Little grub screws that hold the bearings. I just tweaked those up a little bit, which has made a huge difference. It makes everything a lot more rigid. If you give this a tug now, it doesn't move at all. There's a little weakness in this. I might either gusset that or make larger plates. I've put a brace in the frame itself, which has eliminated a huge amount of wobble. I was surprised at how much that big frame wobbles, but it does a lot. So typical kind of plasma holes, not 100% round. You never get them 100% round. It's just plasma. It's not very good for cutting holes at all. Any tight radius it really doesn't like. But you can get away with that. We're just going to bung some screws through it. There's nothing fancy about it, so that's all going to work well. I think I said yesterday that I've kind of tidied up all of these. Everything's looking sweet, actually. Yesterday, like I said, I'd done the spring-loaded side of it. I know there's going to be some people who are going to have a bit of a gripe about me about the spring-loaded, about the bearings in the motors and things like that, but the way I look at it is the time it would take and the money to have a pinion-based sort of bearing transfer gearbox, if you like. It's just not worth it. I'd need 3 of them. They are, a few £100 each, and a motor's, what, 32 quid? So if it does go, what do? You just replace the motor, job done. That's just my throwaway thinking, I suppose, but it's just the way I look at it. It seems a massive ball ache to put on transfer gearboxes when the motors are fine by themselves. So anyway, what I'll do is we'll carry on. I'll just press the play button. Here we are. You can see we're at that point there. So we'll just press play, and we'll watch it go about its business. I'll shut up and you can watch now. By the way, I loop the corners to keep the corners dead sharp so you don't get any weird tracing, arc trailing. There you go. That's those 4 parts cut out. That's something for the guys to get on with first thing tomorrow morning, because it is Sunday today, of course, and I'm working again. I wanted to explain the looping on the corners. Can you see those looped corners? Okay, even at the start of the radius. Let me explain. If you get a normal piece like this, that has had looped corners on it, and the corners are dead sharp on both sides. If you don't do looped corners, and I haven't got a piece to show anybody, if you don't do looped corners, you will get, let me see if I can find a piece, you'll get a little bit of arc trailing. And what here we go. Hopefully you can see that. Can you see how that arc underneath is tighter and it's a bit odd compared to the top half, which is nice and sharp? Let's see if we can find another example. Yeah, on that inside edge there. So you'll see there's a kind of a weird radius there. Don't know whether you can see it. Let's see if we can get it to focus. You can just see that weird radius there. If you look at it at the other side, it's nice and sharp. Look at it on that side, you've got a little bit of a funny old radius. Well, if you loop the corners like this, and if I'm brave enough, hang on, I'll see if I can find a magnet, and what we'll do is we'll pull that one out, and you'll be able to see, there we go, and you'll be able to see exactly what I mean, that these will be, so underneath, look, dead sharp corners. And this is straight off the machine, look. Hardly any dross at all. Means I got my feeds and speeds right. But can you see how crisp? Oh, probably can't because of the focusing. See how crisp that shoulder, that corner is. Both corners. Look at that. That corner is beauty, and that is purely because. And that one. Can you see there is no? If I turn it over without burning myself, again, because of the looped corners, yeah, you get a perfect corner. Unlike, let's see if we can see this. Right. Unlike if you look at the bottom of here, you can see it perfectly there. You've got that. See that radius, and on the top. There, you can see it there. Nice and sharp on the top. Little radius. That is because the arc trails behind the machine. So the arc, instead of going straight down like that, when it goes around, it actually trails like that when you've got the speeds right. You've got to have a fairly high speed so you get rid of the dross. So you can imagine that when the top reaches the corner, it starts to turn, and the arc hasn't actually caught up with it. So if you loop it what you get is it comes back in a square cut. So it leaves on a square cut and comes back in on a square cut. And in that way, you get perfect sharp corners. I wouldn't exactly call it tip of the week, but if you're welding something up, fabricating something, or you're doing a job for a customer, and you want it to be as perfect as you can get it, then bloody well get it as perfect as you can, because the customer expectation is always high with plasma. Most customers, unless you explain it to them, which is quite often a ball ache, think that plasma is laser. It definitely is not. It's not as accurate, it's the edge cuts aren't as square, but it is horses for courses. A plasma cut, in my opinion, is perfect for the general fabrication workshop. And most customers thinks it's laser, and as long as they're happy with it, let them carry on thinking it. Yeah, plasma's not great. It's not great on little holes. I mean, if you look at these little holes, they're not too bad. At the same time, you know, they're not great either. It's just plasma holes, especially this small. Normally I would drill these, but like I say, it's horses for courses. I know what these are going to be used for. Give you an example. They are going to be used for making these things. Now all that is a stand that goes in the ground to hold a bit of timber. So do you think anybody's going to give a shit whether it's a plasma cut, laser cut, fucking disc cut? Then nobody's going to care. So that's the crack. There's some ones that I bashed out earlier. There's the little plates. This is another example here of what I was trying to say about the corners. I didn't loop the corners on these, so you can see that, oh, maybe you can see there's that radius I'm talking about. So on the top, dead square. Underneath, you've got that little round corner. Like I say, it is horses for courses. You haven't always got to loop the corners, but in sheet cam it gives you the ability to loop the corners, and like I say, why not? You don't want to be, you know, you don't want to be handing out rubbish product if you haven't got to. And if all it takes is one setting in sheet cam to loop the corners, then loop the corners. That's what I say. Anyway, I hope you like this little brief video. It's a bit of an addition to the last video. I'll post both up at the same time, join them together as you can with the magickery of the internet. So yeah, all good. I hope you like it. Please like and subscribe. If you've got any questions, then just ask them. I do tend to answer. I answer as quickly as I can. Sometimes I get questions from different parts of the world, of course, and I'm sleeping. I can't always answer straight away, but I'll answer as quick as I can. So please like and subscribe, like I say. Thumbs up or thumbs down. If you've got a thumbs down, please ask why, or tell me why, because don't ask why, but tell me why, because sometimes it might be something that I'm doing, I'm not explaining things correctly, or I got some other issue. So yeah, I don't know everything. I'll never ever know everything about this kind of game. But what I do know is how to make a machine work. Whether it works as accurate or as quick, or as professionally built as some other people out there, because there are some fantastic builds on the internet. There are also some pretty shabby ones. Then that's a matter of opinion. But suffice it to say, I am doing my best. So there we go. Just one other note, incidentally. I know somebody's going to give me a hard time about the torch mount, about what happens if the torch crashes into the material and everything. What I didn't show you is that these are held on with plastic threaded bar, nylon threaded bar. So I've got in there 8mm nylon threaded bar. So if this little baby gets caught, yeah, instead of breaking a 500 quid torch, all that will happen is that these little plastic bits here will just break out. So hopefully they're weak enough to deal with that. If they're not, a friend of mine said you could use magnets. That's a great idea when you consider the backing plate's aluminium. Of course it's not magnetic, not ferrous, so that ain't going to work. But I'm hoping that the plastic threaded bar will do the trick. I've never had a torch crash yet. I think if you're careful and you set things up accordingly, and you use common sense, which of course is not so common these days, you're going to get away with it. You're not going to have any problems at all. So there we go. Anyway, like I say, please like and subscribe. I do like to see the subscriptions going up because it spurs me on to do other stuff. I'm hoping in the next video I'll be able to start to build my machine, because this is for a customer. I've got some finishing off to do. I've got plates and stuff to go on here and bungs in here.